This is the 4th generation device. It is a DIN rail mounted device. You can see the DIN rail mount here, and it can be installed using this clamp. The device comes with 5 CTs. 4 CTs are used for each line. This is the CT for the R phase. You can see the R marking here. It is a 100 ampere CT, and you can also see the arrow indicating the current direction from S1 to S2. You must ensure that the direction of the arrow matches the direction of current flow. This is the CT for the Y phase, indicated by the Y marking here. This is the CT for the B phase, indicated by the B marking here. This is the CT for the neutral phase. You will notice that it does not have any R, Y or B indication. This is the CBCT. All 4 wires R, Y, B and neutral must pass through it. The CBCT is used for earth leakage detection. This is a 4-core cable consisting of R, Y, B and neutral. The R phase is connected to L1, the Y phase to L2, the B phase to L3 and the neutral to N. This device can be mounted directly onto a DIN rail. You can see the mounting arrangement and clamp here. We are now mounting the device onto the DIN rail. As you can see, we place it on the rail, pull the clamp downward using a tester and push the device firmly into position. The device is now securely mounted onto the DIN rail. This is the CBCT. All 4 wires R, Y, B and neutral must pass through it. These can either be the main incoming supply wires or the outgoing cables from the main MCB. The CBCT can be installed either before or after the main supply, but it is important to ensure that all 4 wires pass through it. We are now mounting the CT for the R phase. As you can see, the R marking is indicated here. The direction of the arrow must align with the direction of current flow. We will now remove the R phase cable, pass it through the CT, reconnect it to the MCB and tighten the screw securely.
Similarly, the CTs for the Y, B and neutral phases have also been installed.
Next, we will power the device. We are connecting L1, which is the R phase wire, to the R phase terminal of the MCB. It is important to maintain the correct sequence of R, Y, B and neutral. If you want to enable the trip function in your device, you will need an accessory called a shunt release. The shunt release must be compatible with the MCB being used. Now, let us understand how to connect the shunt release to the device. To enable, this is the required wiring configuration. From the R phase, connect one wire to IP1. From the Y phase, connect one wire to IP2. Take one wire from the neutral terminal here and another wire from the trip terminal of the MCB. These 2 wires will connect to the shunt release. This is the live wire and this is the neutral wire. The 4th generation device is now powered on. As you can see, the power indicator is on, the Wi-Fi indicator is blinking, which means the device is in pairing mode, and the trip indicator is green. This means the device is ready to trip the circuit in case of any electrical fault. You will see a Wi-Fi network called OHMXBOT like over here. Please click on that and enter the password ABCD1234 and connect. It will ask you to sign into a network. Click on that and it will take you to the pairing page. Then scan Wi-Fi network and then you will see all the Wi-Fi networks that are available over here. Now you select the Wi-Fi of your choice and enter the password. Now you will see that your bot is connected to network. As you can see, the Wi-Fi light has now turned green, which indicates that the device is connected to the internet. If the light blinks alternately between green and red, it means the device is connected to Wi-Fi but not connected to the internet. If the light remains continuously red, it means the device is not connected to any Wi-Fi network. Now let us see how the device trips the MCB using the shunt release. and what needs to be done to restore the circuit afterward. The device has now sent a signal to the shunt release to trip the MCB. As you can see, the trip indicator has changed from green to red. To turn the circuit on again, switch the MCB back on. However, the trip indicator will still remain red. To re-enable the trip function, press the red button. Now, the trip function has been activated again. For a single phase connection, the same device can be used without the Y and B phase CTs. Here, you can see the CT for the R phase indicated by the R marking. This is the CT for the neutral phase identified by the absence of any R, Y or B marking. This is the CB-CT through which both the live and neutral wires must pass. Here, you can see the incoming live connection. All you need to do is loop the live connection to L2 and L3, as shown here, and connect the neutral wire accordingly. With this configuration, the same device can be used for a single phase connection. For single phase operation, take the power supply from the live phase here and loop the connections to L2 and L3 as shown. Then, connect the neutral wire to the incoming neutral terminal. This completes the installation and setup process for the 4th generation device.